Hey, it's a beautiful day in this neighborhood. Hope you guys are doing well. Welcome to another Rockstar video about math. Today we're going to talk about ratio tables. If you have not checked out the video on foundations of ratios, you should check it out because it's kind of important. What's black and white and black and white and black and white and black and white and splash? That's a penguin rolling down an iceberg into the ocean. You absolutely know that would be a funny sight. All right, so the lesson target. I'm not going to spend a lot of time on this because it's going to sound very confusing, but at the end it will make sense. I will create a table of equivalent ratios to represent a proportional relationship between two quantities when given a ratio or contextual situation. Blech. That's a lot. Let's explain it. But first, let's get into vocabulary. Proportion. This is very important as you head into the next layers of your math understanding. Proportion says that two ratios, which can be written as fractions, are equal. Okay, so what I want you to think about is equivalent fractions. So let's look at this ratio, which we've used in an old video. We have balloon animals that show a ratio of 1 red to 3, or to 2 green, out of 3, I'm sorry. 1 red out of 3 total. And then we also have this scenario here where we have 2 red out of 6 total. So it's part to whole comparing part to whole. Okay. And in order for this to be a proportion, they have to be equivalent. 1 over 3. So if you go back and think about fractions, 1 over 3 equals 2 over 6. Okay. Again, thinking about equivalent fractions. In order for a ratio to be proportional to another ratio, they have to be equivalent fractions. And how do we know if a fraction is equivalent? Well, we multiply the top and we figure out what the top was multiplied by. And 1 times what is 2? Well, 1 times 2 is 2. So in order for the bottom to be equivalent, it has to be multiplied by the same value. And 3 times 2 happens to be 6. So yes, if we multiply the top and bottom by the same number, we are going to get proportional ratios, okay? So proportional relationship, very similar to what we just talked about. Two variables that have a proportional relationship if the ratios of the variables are equivalent. So it's really just the same thing as the last one, but it's just thinking about when we think about proportions, we know what the definition is. A relationship is, yeah, these two things have a relationship that says they're proportional, like this. So the same scenario we just had, if we have 1 to 3 is equal to 2, 6, well, we can figure that out and say they are equivalent to each other, so they have a proportional relationship. This other one, we could say 1/3. All right, we can say 1/3 is equal to 1/2. And we could say, is that proportional? Well, what did I do on the top? I multiplied by 1. What did I multiply by the bottom? I did not multiply by 1 because 3 times 1 would be 1. So that did not work. So that makes it not proportional. We're going to get into a little bit of that in a second. And so a ratio table is simply a way of showing proportions that have a relationship that says it's a proportional relationship. So it's a table that is used to describe the relationship between these two separate quantities. So in other words, for this one, for every 1 dog, I have 3 cats. So if I have 2 dogs, I have to have 6 cats. If I have 3 dogs, I have to have 9 cats. If this is a proportional table, then all those have to be ratios that are equivalent fractions. Again, let's dive into that. So let's talk ratio tables. First of all, a ratio, as a reminder, is a way of comparing any two values, okay? Ratio tables let us explore the proportional relationships that are created in the initial ratio. So the very first ratio we figured out. So maybe in the past you had a table. So I don't want you to think all tables are proportional because they're not all proportional tables. But maybe in the past you've looked at a table, which is a collection of values on one side and a collection of values on the other, and you use addition to find a pattern. Maybe your teacher said, look at this table and see if you can figure out a relationship. Okay, so you might look at this and say, oh, I see. This table shows I take 2 and I add 8 to it and I get 10. Well, let's check and see if that's true. Yeah, 3 plus 8 is 11. 4 plus 8 is 12. 5 plus 8 is 13. There's my pattern. Okay, and that shows a good addition relationship. But in order for this to be a proportional table, we have to take that first one, which is 2 out of 10. So 2 out of 10. And we can compare it to another one. You can compare it to any of them in here to find out. We're going to compare it to this one over here, 4/12. Okay, and let's find out if it's proportional. Well, if it's proportional, whatever we do to the top, 2 times 2 is 4, we have to do to the bottom. And if we multiply 10 times 2, if we multiply the bottom by 2, we're going to get 20. So in order for 10 to get to 12, you actually multiply by 1.2. Did you multiply by the same as the top and bottom? No, you did not. So these are not proportional. There's nothing wrong with this table. It's just not a proportional table or a ratio table. So this is just a collection of data. For a ratio table, we have to use multiplication because remember, we talked about that. That's how we find equivalent fractions. So in this table, we use multiply every x by the same number to get to y. Okay, so let's look at this. Here's a table. All right, so what do we multiply 2 by to get to 10? 5, right? 2 times 5 is 10. So if we're making a ratio table, we have to do that same rule every time. So let's look at 3 and multiply it by 5. It's 15. You see I'm multiplying, not adding. 4 times 5 is 20. 5 times 5 is 25. Okay? You could also do this division. Multiplication and division, if I had one side of the table and it was bigger and we were getting smaller, that's fine. But we don't use addition and subtraction, okay? So our ratio table has 4 equivalent fractions because we multiplied all of them by the same number. So does that mean if they're all multiplied by the same number, that means we've created equivalent fractions, which means, yep, that's proportional. Let's try another one. Make a ratio table with a ratio of 3 to 9. So now we're going to make one. So here's our table. And I put 3 on one side, 9 on the other. Okay? So what do we multiply 3? What do we multiply 3 by to get to 9? That's correct. We multiplied it by 3. So what do we have to do? We have to multiply them all by 3. Okay? By the same value. 4 times 3? 12. 5 times 3? 15. 6 times 3? 18. So since all members of this table have been multiplied by the same rule, this is a proportional relationship, or it's a ratio table that works. Not too shabby, huh? What about if we make a ratio table of our own given a scenario? So the ratio of TVs to homes in my neighborhood is there are 6 TVs to 4 homes. So we put this in here. You can put them in either order if it's not X and Y, it doesn't matter. Okay? So we have homes is 4. As long as I said homes is 4, I have homes and it is 4. And I'm saying TVs is 6, TVs is 6. So everything I have set up so far works. So what do we multiply 4 by to get to 6? Now this is a hint. I don't know what 4 times 6, 4 times something equals 6 because it's going to be a decimal or a fraction, right? So if I can't figure out what to do to here to multiply, I go backwards and I divide. Figure out what I would do. 6 divided by something, or 6 divided by 4 will give me an answer. So what is 6 divided by 4? It's 1.5. Okay, so then I could go back and reverse that, turn it back into multiplication, and say that 4 times 1.5 equals 6. So we use the inverse operation to figure out that value. Okay, so what do we have to do? The same thing for everyone. 5 times 1.5 on the calculator is 7.5, or you can do it on your paper. 8 times 1.5, that is 12. 10 times 1.5, that is 15. So everything was multiplied by the same number. So we have 4 equivalent fractions. Does that make it a proportional relationship? You're darn right it does. All right, guys, I think you guys are ready to go. Let's fill out our fill in the blank. Ratio tables are a way to compare or describe the proportional relationship between 2 quantities. Okay, so we're given a ratio and then we turn it into a table by bringing more quantities into it. So a ratio table uses multiplication to define the rule between the x and the y. So in order to get from one side to the other, we figure out what we multiplied by, or the opposite direction would be division. All ratio tables must be equivalent. All ratios in a ratio table must be equivalent in order for it to be a proportional relationship table. Sorry, a proportional ratio table. If you multiply the top one by 2, the second one by 2, the third one by 2, and the fourth one by 5, it's not proportional. So you got to check them all. And then finally, if finding the multiplication rule is hard, use division. Go in the opposite direction to find the rule. All right, I think you guys are totally getting this. Speaking of black and white, black and white, black and white splash, what's black and white and red all over? That's an embarrassed penguin. Oh.